Good morning, class. We are looking at exam 1 review, which covers from 1.6 to 3.1. 1.6 sequences and difference equations, 2.1 limits of sequences, 2.2 limits of functions at infinity, 2.3 limits of functions at finite numbers, 2.4 limits algebraic method, and derivatives and rates of change. The questions come either from your lectures or the exam review, which is posted under the modules in MOM. So here's the exam review question number 4. We want to find the general terms. And this is as complicated as it gets. It has 3 parts: the sign, the numerator, the denominator. The reason we discuss the sign, because it alternates. Therefore, when we are done, we end up with this format. We replace each one accordingly. The sign is either -1 to the power of n or -1 to the power of n minus 1. The question is which one. If you choose n to be 1, this becomes -1. If you choose n to be 1, this becomes +1. And therefore, because the first term is positive, that would be the choice. You write the numerators, 6, 10, 14, 18, 22, and so forth. You notice it's an arithmetic sequence because the first term is 6. And we add a constant for d equals 4, a sub 1 equals 6. Therefore, a sub n equals a sub 1 plus n minus 1 times d. Replace the a sub 1, replace the d. These two add up to give us 2. Denominators, 3, 9, 27. That is a geometric sequence with the first term being term a sub 1 and also r being 3. So a sub n equals a sub 1 r to the power of n minus 1. Replace each one. Notice this has exponent 1. We can use this and add up the exponents to get 3 to the power of n. Now we are ready to plug in. When we do that, we check. So we have -1 to the power of n minus 1, the numerator 4n plus 2, and the denominator 3 over n. If I replace the n with 1, this becomes -1 to the power of 0, which is 1. This becomes 6. This becomes 3. So we get 6 there. The first one can check. And I highly recommend you do more checking. You can check your work. Find the first 5 terms where a sub n is 2 to the power of n minus 4. The first term would be 2 to the power of 1 minus 4 negative 2. The second one would be 2 squared 4 minus 4 is 0. The third one would be 2 cubed 8 minus 4 is 4. And the rest of them. Again, as long as you can show work for 1 and 2 to be on the safe side, 2, then you can show work for more. No need to worry about that. Find the first 6 terms of the recursive sequence where a sub 1 is 2, a sub 1 is 2, a sub 1 is 1, a sub 2 is 2, and a sub n plus 2 is a sub n plus 1 plus 2 a sub n. What does that mean? That means if you want any term, go to the previous one, and then plus 2 times the one before that. So if I want a sub 3, I go to the previous one, a sub 2, and then 2 times a sub 1. So this is 2. This is 2 times 1, adds up to 4. if I want a sub 4, so if this is 4, this is 3, this is 2. So a sub 4 is a sub 3 plus 2 a sub 2, which means 4 plus 2 times 2 adds up to 8. If I want a sub 5, I pick the previous one, a sub 4, and then 2 times the one before that, which means I pick the previous one, 8, and 2 times 4, 8, adds up to 16, and I can write 6 terms. Finding the sequential limits, and these are some theorems that we have discussed. And so now just plug in and observe. You plug in infinity, 2 to the power of infinity. When you have the limit of r to the power of n as n approaches infinity, when r is larger than 1, it's infinity. You should know this theorem. Part B, you plug in, you should know exponential rules. Therefore, this part becomes 1 over 2 to the power of infinity, which is 0. The answer is 5. It converges. Again, if they don't ask you, you don't have to mention that. In this case, it diverges. In this case, it converges. Plug in 1 over infinity is 0, just following this theorem in essence, and it converges to 1. When you want to take the limit where the given expression is a rational or fractional format, and n or x approaches infinity, the technique is to divide by highest degree term in the denominator, namely n squared, and simplify. So there are 3 terms at top, 3 at the bottom. Everything divided by n squared results in this. And notice all of these 4 terms, they have a denominator which is n or n squared, or if they don't have it, something n to some power. Each one goes to 0. The answer is simply 2 over 5. Express 0.46 bar as a rational number. Remember, rational number is a fraction where the top and the bottom are both integers. So 0.46 bar means 0.46 and repeat 46. That means you're adding this to this to this, and you continue, and you can go with fractional format or decimal format, makes no difference. If you go with the fractional format, this is 46 over 100. I don't want to even simplify it because I want to make sure we understand that. And the second one is 46 over 100 squared and continues. If you want to go with the decimal format, it's 0.46, 0.0046, and it continues. So we notice this is a geometric series we are adding such that the first term is this in the fractional format or decimal format, 0.46 or 46 over 100. What is R? This number is 100 times larger than this number. So the fraction is 100 times smaller. So R is 1 over 100 or 0.01. So first, A is 46 over 100 or 0.46. R is 0.01, and because it's between -1 and 1, we can use the easy way out. So we are going to write S sub n is 46 over 100 over 1 minus 100, either in the form of a fraction or decimal. If you go with a fraction, you have to multiply the top and the bottom by 100 because it's a complex fraction. This gives you 46. This gives you 100 minus 1, which is 99. So 46 over 99. If you want to go with the decimal, you get 0.46 in the numerator, 0.99 in the denominator, and of course you got to get rid of the decimals, you get to the same answer. Here's from exam review question number 10, 3.16 bar, which means the bar is at top of number 6, which means 3.1, and it's only the 6 that repeats. So the repeating part, we can write it in this format. This part, we can write it in one of these formats, either sum of fractions or sum of decimals. Either way, we notice the same situation. It's a geometric sequence. The first term is 0.06 or 6 over 100, or notice this is 1000, which means it's 10 times larger than 100. So the fraction is 10 times smaller. So R is 1 over 10 or 0.1, and therefore we are going to go with A over 1 minus R. So this part, we are going to add them up, is the sum of this number, and this part, A over 1 minus R. This is A over 1 minus R. I use fraction or I use decimal. Either way is fine. I'm going to show you both ways. If you go with fraction, it's a complex fraction multiplied by 100 over 100, which means, again, this remains unchanged. The product of these two is 6. The product of these two is 100 minus 10. And so you're looking at a 6 over 90. Please understand, 6 over 90 is the same as 2 over 30. Please understand, 0.1 is 1 over 10. And 1 over 10, I can write it as 3 over 30. They add up to 5 over 30. 5 over 30 is 1/6. So 3 and 1/6. This is your final answer, and it's fine. If they wanted in a from a mixed number format to improper format, 3 times 6, 18 and 1, 19 over 6. For me, either one is fine. I want to show you the decimal format here. If you want to go to the decimal format, and you could write 0.06 over 1 minus 0.1, 0.9. Okay, you have to multiply the top by 100 to get rid of the decimal. You're going to multiply the bottom by 100 to get rid of the decimal, which is the same number we got here. The point being, fractions, decimals, they're the same. You should be able to handle both. Okay. A doctor prescribes a 100 milligram antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 30% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 in terms of Q sub n. First and foremost, you want to know what's given when you read the question, and 8 hour is a very important number. It's the time step, but doesn't enter any of the formulas here. So in this formula, you need to know the R and C. Lowercase c is the amount of constant. B sub 0 or A is the um, initial value, which is in the case of, which is 0 in the case of dealing with patients. So B0 or A. And the reason I'm giving you part B, so I want you to know we are going to go with Q. So instead of B sub 0, we're going to say Q sub 0 or A is 0. And the constant, they give the patient the 100 milligrams antibiotic. And what is R is the percentage that remains in the body, 0.3. And it's important to understand that they either give you what remains or what is gone, what is absorbed, in which case you have to subtract it from one. So we want the how much drug is left after the third tablet. If you want to make up a table, what happens, this is Q sub 1, we have 100. In the second one, we have the same 100, and what is left of it? 30% of this. 30% of this is 30, and we add a constant 100, it gives us 130. Now Q sub 3, again, we are adding 100 and 30% of this, which is 39. So 139. We want to write this formula, and we are going to go with this one and change the B to Q. Q sub n plus 1 is R Q sub n plus C. And you don't have to go too far. You have the given here. Just replace the R and C, and it becomes 0.3 Q sub n plus 100. It's very simple, everybody. Now, when we look at this formula, we change the B to Q, solve the formula for Q sub n as a function of n. Q sub 0 is 0, of course. So just plug in to this Q instead of B, and now go back to the given. Q sub 0 is 0. We're dealing with patients. And what is R? 0.3. What is lowercase c? 100. This goes to 0. This is 0.7. And we take it out, and we make it 100 over 0.7. Or 1000 over 7. And because the fraction doesn't simplify, you keep it as 1000 over 7. This is an exact answer. And if they ask you to give them with, approximation, then however many decimals. Otherwise, you keep it. Use part C to find Q sub 3. All you have to do replace the n with 3. I highly recommend you try it. I leave it for you to try it. You must get 139, and you will. Try it. Plug in n equals 3. Finally, what is the limiting value of the concentration? That means take a limit of this expression as n goes to infinity. And again, we remember the theorems. When n goes to infinity, you can take this out. And when you apply the limit, this, because it's between -1 and 1, this goes to 0. So the answer is 1000 over 7, or 142.857 milligrams, which means if this antibiotic is taken every 8 hours, it will never, ever get beyond this much, 142.857 milligrams, and that happened to be safe for the patient. We want to find the limit. And of course, if you plug in, you get infinity over infinity. Okay. Remember, to find the limit, just plug in. You get a number. You're done. You get 0 over a number. You're done because it's 0. You get a number over 0, you have to figure out if it's infinity or negative infinity, because 0 is the only number that the left side from the left is negative, from the right is positive. That's why it may go to infinity or negative infinity. And finally, in calculus, we most of the time end up with indeterminate forms of 0 over 0, infinity over infinity, infinity minus infinity, and there are other forms, which means you use your algebraic technique to fix the problem, which means more work. So for example, right here, if you plug in, you get infinity over infinity. Because it's a fraction and because t approaches infinity, you divide by highest degree in the denominator, which is t squared, the top and the bottom. And you simplify. Everything has the denominator t, or t squared goes to 0. So everything goes to 0 except this. So it's 0 over 1. And again, 0 over any number is 0 other than 0, okay? The number other than 0 in the denominator. This one, if you plug in, you get infinity over infinity. But because it's a fraction, I mean, because t approaches infinity, you divide by highest degree term in the denominator, namely t. And you simplify. When you do that, this goes to 0, this goes to 0. But this is infinity. So what you have, infinity plus 2 in the numerator, 5 in the denominator. As I've mentioned before, infinity plus any number is infinity, or infinity minus any number. Divided by any number is infinity, except if it's being divided by a negative number, it's negative infinity. So in this case, the denominator is positive 5, so it's positive infinity. The limit of the square root of x squared plus 1 minus x as x approaches infinity, if you plug in, you get infinity minus infinity. Because it's a square root, you multiply by the conjugate and you divide by conjugate. That means plus x, okay? So for the denominator, you just keep it. For the numerator, you have the product of these two pieces, which becomes square root of x squared plus 1 quantity squared minus x squared, which becomes x squared plus 1 minus x squared. These two cancel each other. And now, when you plug in infinity, the denominator is infinity plus infinity, and you prove that it's 0. So again, indeterminate, infinity minus infinity, happen to become 0. That's not the case always. We want to solve this. We just plug in. And because t approaches infinity, e to the power minus t is 0. Because, reminding you that a to the power minus m is 1 over a to the power of m. So e to the power minus t is 1 over e to the power of t. And therefore, 1 over e to the power of infinity and 0. 12 over 4 is 3, and we are done. This one, if you plug in, you get infinity over negative infinity, because this is 5 plus e to the power of infinity, that's infinity. 4 minus 3 times e to the power of infinity is infinity. So negative makes it negative infinity. So what is the technique? This is not a rational function, but it's a fractional format. So you divide by highest value in the denominator. The highest value in the denominator is e to the power of t. And you simplify. When you simplify, you notice this is 5 to the power of 5 over e to the power of t, and this is 4 over e to the power of t. Each one goes to 0. So you have positive 1 over negative 3, negative 1/3. Limit of x squared minus x as x approaches infinity. If you plug in, you get infinity squared minus infinity, which is simply infinity minus infinity, and makes it indeterminate. What technique do we use? We factor the x out. If we plug in, we get infinity times infinity minus 1. That is infinity. And we are done. Again, in the previous page, infinity minus infinity ended up being 0, while here we get infinity, and in some cases we get something else. Okay. Again, you're dealing with a rational expression, and x is approaching infinity. You divide by highest degree in the denominator and simplify. If you plug in, you get infinity plus 1, and you get 0 minus 1. It's important to understand the numerator is infinity, and the denominator is a negative number, negative 1 or negative 10 billion. The answer is negative infinity. That's why I want you to be careful with the sign. Limits of functions at finite numbers, reminding you of one-sided limits. A function has a limit at a if the limit of f of x as x approaches a from the left and the limit of f of x as a approaches from the right are identical. So we want the limit of g of x as x approaches 2. Therefore, we're going to look at the left and right. So 2 from the left is this way, is here, and is taking us towards this point, and the answer is 3. From the right of 2, we move this way towards this hole. The answer is 1. Are these two the same? No, the limit does not exist. The same thing for number 5. We want to find the limit of g of x as x approaches 5. That's why we look at the one-sided limit. So let's go with the limit as x approaches 5 from the left. As you can see, it's moving towards this point. When we approach it from the right, the same thing happens. It's approaching the same point. Remember, we never get there. And this point has a y coordinate 2. Therefore, the limit is equal to 2 because they are identical. If we assume this point is about 1.4, g of 5 is 1.4, which is not equal to 2. This is a discontinuity. This is a discontinuity. This is a jump, and this is a removable discontinuity. So the definition of a continuity, limit of f of x as x approaches a equals f of x. G of x can be CTS, continuous, at x equals 5 if we redefine g of 5 instead of, see, g of 5 is 1.4. If we redefine it to be equal to the value of the limit 2, then it fixes the problem. That's why this is called removable discontinuity. However, this is a jump. We can't fix it. And what is g of 2? That is undefined. It's not given. So we should be able to read graphs when it comes to limits. We're going to do it here, reminding everyone about the definition of a VA, vertical asymptotes. When the limit of f of x when x approaches a or a from the left or right is negative or positive infinity, x equals a is the vertical asymptote. So as we look at this one, true. The limit of r of x as x approaches 2, you are moving towards negative infinity. Whereas 5, from both sides of 5, we go to positive infinity. And negative 3 from the left. We move towards negative infinity. And from the right, positive infinity, which says x equals 2, x equals 5. These two mean the same thing. X equals negative 3 would be the vertical asymptotes. Okay, vertical asymptotes. From exam review question number 25, if you plug in 1, you get 4, and square root of 4 is 2 minus 2 is 0. 1 minus 1 is 0. So we get 0 over 0. The technique is using your algebraic techniques to fix the problem because 0 over 0 is indeterminate. And so what do? You multiply by the conjugate of the numerator and you divide by. And so when you do that, you keep the denominator as a product. This becomes square root of x plus 3 squared minus 2 squared, which is minus 4. Obviously, 3 and minus 4 combine to x minus 1. We can drop these two and the numerator becomes 1. If you plug in 1 here, you get 4. Square root of that is 2. 2 and 2 is 4. So 1 over 4 is the final answer. I'm putting these two questions next to each other, okay, because I want you to see whether x approaches 6 from the left or right really doesn't make any difference for the top, because from the right, this is 6.000001. Okay, 6. From the left, this is 5.999999. So the top is 6 and the bottom is 0 in both cases. However, again, very close to 6, very close to 6. It doesn't matter left and right or both positive. 0 is the only number that left side is negative, right side is positive. So you have to check to see what happens. To do so, you plug in 6 from the right. For example, if I put 6.1, okay, minus 6, I get 0.1, which makes this one positive. Okay. However, this one, if I put it like 5.9 minus 6 gives me negative 0.1. That means 0 from the left. That makes that negative. So what is the difference? Both of them are infinity, but this is positive, this is negative infinity. And that is important to understand how you recognize positive versus negative infinity. What is the limit of natural log of x squared minus 16 as x approaches 4 from the right? I hope you recognize that if you plug in a 4, you get 0. But 0 from the right. 4 it's a little bit larger than 4. So when you square it, it's a little bit larger than 16. So it's 0 from the right. And I hope you remember the graph. Therefore, that gives rise to negative infinity, which means the vertical asymptote has the equation of x equals 0. So that, again, reminding you that the vertical asymptote is the y-axis. VA is the y-axis, or x equals 0. This is from exam review, and we are going to find the limits. And I hope you understand. You plug in, you get 0 over 0. Factoring is the key. Because x is approaching -5, remember, this means we must have a factor of x plus 5, and we do. The numerator, the x comes out, and the denominator is a squared minus b squared. Because 25 is the same as 5 squared. So we have x times x plus 5 over x plus 5 times x minus 5. The common factor of x plus 5 drops. If I plug in -5, then I get -5 over -10, or positive 1/2. Let me just actually write it here. -5 over minus, okay, erase it and write this. If I plug in, I get -5 over -10, which is positive 1/2. Plug in, you get 0 over 0. It's a complex fraction. You need the LCD, 3x over 3x. So you multiply the top, and you multiply the bottom. The bottom remains as a product. This times this is x, this 2, give us -3. They cancel each other. You plug in, you get 1 over 9. Again, by the way, those are questions 32, 33, and 34 from the exam review. You plug in. If you replace the x with 0, this goes to 0. Square root of 16 is 4. So it works out. Again, remember, you plug in. If it works out, you're done. Here's another example that works out. If we plug in, the numerator becomes 36 minus 36. The bottom becomes 6 minus 3. Just try it. Because it's 0 over 3, it's 0, and you're done. It just works out. And this one, if you plug in, you get 0 over 0. This one, if you plug in, you get 0 over 0, everybody. So what is the technique? The technique is to multiply and divide by the conjugate. which is the same thing, but with a plus sign. 0 over 0, you do this. Now, what happens to the bottom? Nothing. You keep it as a product. What happens to the numerator? Square root of 49 plus h quantity squared minus 7 squared. So 49 plus h minus 49, these two cancel each other. The numerator is h. This cancels this one and results in 1. And now if you plug in 0, you get 49 here. Square root of 49 is 7 and 7, 14. 1 over 14 is the final answer, everybody. If you plug in, you get 0 over 0. The technique is factor. And it's very easy to factor. First of all, x is approaching -4, which means you should have a factor of x plus 4. That helps. Just bear in mind that one. So this is x, and then 3x, and this is x, and then 2x, because this is number 3, it's a prime number, so it has to go with 1 and 3. And since you know most likely you have to have a factor of plus 4, you can put plus 4 and figure it out. Or just think about this. -4, you have two choices. 1 and 4, one of them negative, or 2 and 2, one of them negative. In this case, 12, you have many choices. You can do 1 and 12, you can do 2 and 6, or 3 and 4. But we said this tells us we need a plus 4, everybody. So it makes it easy to figure out the rest. Okay? And you drop the common factor of x plus 4. You get the limit of 3x minus 1 over 2x plus 3 as x approaches -4. So if I put -4 here, I get -12, and -1 is -13. Over here, I get -8 plus 3 is -5. Negative over negative makes it positive. So the technique is factoring. You should be very comfortable with factoring, everybody. This is the concept we just looked at, derivatives and rates of change. Remember the good old rise over run. Slope of a line, you need 2 points, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or delta y over delta x, known as the rise. So what is this? F of x minus f of x minus f of a over x minus a. You're looking at this blue line, which is the secant line. What is this? If you go with this format where this distance is h, we go from a to a plus h. So the run is h. And over here, f of a plus h minus f of a is the rise. So this is the numerator and h is the denominator. So please understand they're all the same. And of course, if you call this b, then you have f of b minus f of a over b minus. And of course, what's happening here? We are trying to get to from the blue lines that are the secant line, we want to get to the red line, which is the tangent line. The tangent line is the limiting position of the secant line PQ as Q approaches P. Slope of a tangent line, also known as instantaneous rate of change. M of tangent is the limit of M PQ, okay, right? As Q approaches P. Or limit of f of x minus f of a over x minus a as x approaches A. For this one, as x approaches A. For this one, as h approaches 0. Both of them are good. And so we call it f prime of A. We want the equation of a tangent line, everybody. Standard form, ax plus by equal to c. Point slope, make sure you learn that. Y minus y1 equals m times x minus x of 1. And slope intercept form, y equals mx plus b. So equation of a tangent line at this point, which has coordinates a comma f of a, becomes this according to the point slope. Y minus y1 is f of a. M is f prime of a. X minus x of 1 is a. Do I have to memorize that? As I mentioned it many times, no, just write the point slope and follow that. For example, we want to find the equation of a tangent line to the parabola y equals x squared at this pair. And here we have the function y or f of x equals x squared, a equals to 1. We are going to find the slope, and I'm going to do it both ways for practice. And we're going to use this one for now. Limit of f of x minus f of a over x minus a as x approaches a. So f of x is, and of course we want f prime at what point? 1. And f of x is x squared, f of 1. You can plug it in or the y is given. Again, sometimes they might just give you x. So if they said x equals, I don't know, 4, then y is 16, okay? This can be factored using a squared minus b squared is a minus b times a plus b. And we get x minus 1 times x plus 1. And we plug in, we get 2. Y minus y1 equals m times x minus x of 1. So y minus 1 equals 2 times x minus 1, which is 2x minus 2. This one becomes plus 1. And the answer is 2x minus 1. And you can check it by plugging in the pair. It's a good idea to plug in, and because this point belongs to the graph, also the tangent line, and you're done. However, I think it's a good practice to look at the second method, okay? And of course, A is the same, A1. What is f of 1 plus h? You put 1 plus h squared. What is f of 1 is 1. And 1 plus h squared, a plus b squared is a squared plus 2ab plus b squared. So 1 squared is 1 plus 2 times 1 times h, 2h plus h squared. These two cancel out. We factor the h out from the numerator and we cancel them out. And now if you plug in 0, you get the same slope, which is 2. The purpose of that is just practicing, nothing else. You don't have to do both ways, but you should know how to do them both ways. Sometimes one is easier than the other. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40. We just did that. Where t is time in seconds. What is the average velocity from 2 to 4 seconds? Even if they don't mention it, because 2 points in time is given, you should know it's the average. So in short, the total distance over the total time. So s of 4 minus s of 2 over 4 minus 2. We are going to plug in 4 minus, we're going to plug in 2 and evaluate. So we end up with, this is 16, so we get 32 minus 20 plus 40 here. We get 8 minus 10 plus 40 here, which is 52 minus 38, which is 14 halves or 7 feet per second. What is the instantaneous velocity of the object at 4 seconds? Even if they don't mention instantaneous, one point in time, that's what it means. And that means differentiation. Remember, S prime is the velocity, okay? The derivative of the distance or position function is the velocity function. And of course, A is 4. So we're going to evaluate this and this one. So plug in 4 plus h into the function s of t and evaluate it. Now plug in 4. Because we've done already s of 4, I'm going to use the same number that we did evaluate. Now 4 plus h squared becomes 4 squared, which is 16, plus 2 times 4 times h, which is 8h, plus h squared. We are going to distribute the 2. We get 32 plus 16h plus 2h squared minus 20 minus 5h. And so, take a look at all the numbers. 32 minus 20, positive 40, minus 52. What happens? All of it, they add up to 0. What is left? 16h and minus 5h, they add up to 11h. So we have 2h squared plus 11h. We are going to take the h out. And now we apply the limit by replacing the h equals 0. We get 11 feet per second. And anytime you do word problems, make sure you answer with proper units. 2.5, continuity. Here's the definition of a continuity. Limit of f of x as x approaches a equals f of x. And of course, how do you get to the limit if one-sided limits are identical? So the question is g of x continuous at x equals negative 2 y of y naught? The first question, the first thing I want to address, y at x equals negative 2. Each piece is a linear function and it's continuous from negative to positive infinity. So this one is therefore continuous from negative infinity to negative 2. This one is continuous from negative 2 to infinity. The only thing you check is the endpoint, namely negative 2. So you look at 3 things: the function value, the left side, and the right side limits. And to do so, the function value requires the equality. We go with the equality. That means we're going to evaluate this function x minus 1 and when x is negative 2. I've explained this means such that, and you end up with negative 3. The left side limit less than uses this piece. This is a piecewise defined function. It uses the top piece and we plug in negative 2. This becomes negative 1 and 3 is positive 2. The right side limit uses the greater than, so uses this piece. And if you plug in again, you get -3. The limit from the left and right, are they identical? The answer is no. The limit does not exist. Therefore, G is not continuous, or it's discontinuous at x equals -2. Now, what I want you to notice, we're done. It's not continuous. However, because these two values are the same, the question is g of x continuous at x equals -2 from the right? And the answer is yes, okay? This is the functional value, and this is the limit from the right. That's why the answer is yes. Why? These two are identical. However, it does not change the fact that the function g is not continuous at -2.